Welcome back to our classroom. Here we are going to discuss about energy. In the last class we have seen about work done, right? Work and work done. And in this session we are going to see about energy. Generally, what is energy? We have energy? Yes, of course we have. And how we can define the energy? Yes, the capability of do a work, right? If you have any energy, then only we can do that work, right? Now let's move on to our topic. The topic is energy. So what is energy? An object that possesses energy. Take any one object that possesses energy can exert a force. If it has energy, definitely it will exert some force on another object. Going to apply the another object. When this happens, when if you are applying a force to the another object, energy is transformed from the former to the later. What is the former here? Yes, the first one, the object that possesses energy. What is the later? Yes, the force on the another object. Force on another object, that is called later. So if you are applying the force, what will happen? Yes, the second object may move as it receives the energy. Where it will receive the energy? Yes, from the first object, because the first object possesses the energy. Therefore, the second object receives the energy and therefore do some work. Thus, the first object had a capacity to do work. Yes, the first object had a capacity to do work. This implies that any object that possesses energy can do work. Yes, so if you have possess energy, definitely it will do some work. The energy possessed by an object is measured in terms of its capability or its capacity of doing work. Its capacity of doing work, that we are saying that energy. The unit of energy is very resemblance to work. The unit of energy is very resemblance to work. So what is the unit of work? Joule, right? Yes. Either you can write small j o u l e or capital J. Any one notation you can use. And for higher quantities, 1 kilojoule is equal to 1000 joule, or you can write 10 power 3 joule. 1 kilojoule is equal to 1000 joule, or otherwise you can write 10 power 3 joule. Is it clear? I hope you understand well. Thank you. See you in the next video. And here we are going to discuss about the various forms of energy. So what is the various forms of energy you know? Yes, mechanical energy, electrical energy, chemical energy, light energy. We have so much of energy, right? So here we want to know about what is the different forms of energy, and in the different forms of energy we are mainly going to concentrate the mechanical energy. In that portion in our syllabus we have only potential energy and kinetic energy, and rest of them we should know what is it, right? Okay. In mechanical energy there are two types. One is potential energy and another one is kinetic energy. Potential energy means the object which is at rest that possesses the energy, that is called potential energy. And kinetic energy, the object which is moving, right? That moving object having the kinetic energy. And heat energy is a form of liberating some heat, right? That is heat energy. And chemical energy, due to chemical reactions, the energy conversion takes place, that is chemical energy. And electrical energy is due to current. And light energy, from we are receiving from sun and we are getting some light energy, right? So these are the different forms of energy we will have. And here we want to move here we move on to kinetic energy first. What is kinetic energy? I am standing in front of you without moving. Do I have any kinetic energy? No, okay. Simply I am sitting. Sorry. Simply I am standing right in front of you. Suppose if I am moving, okay, now I will have, yes, kinetic energy. So how to define kinetic energy? The kinetic energy of an object is the energy possessed by it due to its motion. So whenever if you are moving, due to its motion only that have the energy possessed, that is called kinetic energy. And one more way we can define the kinetic energy. The kinetic energy of an object moving with a certain velocity, is equal to the work done to make it acquire that velocity. So acquire that velocity, or that we need to do some work done. So that certain velocity, the moving with a certain velocity is equal to the work done to make it acquire that velocity. Simply we can write the kinetic energy equation is 1 by 2 of mv square. Kinetic energy is equal to half mv square, we can write. Otherwise I can write very clearly. Kinetic energy equation is half mv square, where m is mass of an object and v is velocity of a moving object. It's clear? Yes, I hope you understand well. And here, and the next we are going to derive the equation of this, how we are going to derive this equation of mv square, right? Thank you. And in this video we are going to derive the equation for kinetic energy. As we know, the kinetic energy is the energy possessed by an object when it is moving, right? And in that situation, we are going to derive the equation for kinetic energy. So, how to derive? So, how to start with that question? Consider a mass of an object m. It has constant velocity. How it attains constant velocity? Yes, we are applying a constant force to that object so that it attains some velocity, right? So we are going to calculate the kinetic energy of a moving object. From equation of motion, right? V square minus u square is equal to 2as. Among three equations of motion, this is one of the equation of motion, right? V square minus u square is equal to 2as. And in that from that equation, we can write S is equal to V square minus U square whole divided by 2a, where S is displacement, V is final velocity, U is initial velocity, A is acceleration. And we know that force is equal to mass into acceleration. Force is equal to mass into acceleration. F is equal to ma. And we know that work done is equal to force into displacement. Work done is equal to force into displacement. Yeah, W is equal to F into S. So here we have S, right? Displacement. This is displacement. Here we have work done, W is equal to F into S. What is F? M here, right? Mass into acceleration. So W here, instead of F, mass into acceleration, instead of S, here we have V square minus U square divided by 2a. So we can cancel over this a and this a. Therefore, we will have 1 by 2 m V square minus U square, and this is we have stated that change in kinetic energy, that will be equal to work done, right? Okay. If u is 0, why? Because initially it is stationary. After applying the force only it started, right? So u is 0. Therefore W is equal to 1 by 2 m bracket V square minus U square. This term is 0 mean what will happen? W is equal to 1 by 2 m square. So what is W? Work done. As we have studied in the definition of kinetic energy, the kinetic energy is defined as the certain velocity is equal to the work done attained by that velocity, right? So W is equal to E suffix K. K stands for kinetic energy, that is equal to half mv square, and work done is equal to work done is equal to change in kinetic energy. This is also one of the important sentence. Work done is equal to change in kinetic energy. So E case is E suffix k is equal to half m square. From that equation we can write that's the kinetic energy possessed by an object of mass m. M is mass and moving with uniform velocity v. Therefore, kinetic energy expression is half m square. I hope you understand well. Thank you. Here we are going to discuss one problem. The problem is the kinetic energy of an object of mass m moving with a velocity of 5 meter per second is 25 joule. So consider an object that having the mass m moving the velocity of 5 meter per second and its kinetic energy value is 25 joule. What will be its kinetic energy when it is velocity is double? What will be its kinetic energy when its velocity increases 3 times? So the given what are they given? Mass is m and velocity v. What is the value? 5 meter per second. What is the energy value? Kinetic energy 25 joule. Right? So they are asking what will be if the kinetic energy is double. If V is doubled, what is the kinetic energy value? If 3 times, what is the kinetic energy value? It's clear? Yes? Okay. So we have the formula of mv square. That is the equation for kinetic energy. So what is the value they are given? 25 joule. The kinetic energy of this value is 25 joule. If V is 2 times increases. So instead of V, I can write 2V to the whole square. That is equal to, okay, we can write, okay. So what is 2 square? 4, right? 4, 1 by 2, m v square. It's clear? So 2 square is 4, remaining 1 by 2 m v square. So what is the half m v square value? Yes, half m v square value is 25 joule. Therefore, the answer is 100 joule. If the velocity is doubled. Similarly, if the velocity is tripled, then 3 square is 9, 1 by 2, tripled, right? The velocity is, yes, tripled. So V should be replaced as 3V. So 1 by 2 mv square. So 9 into, what is the value of 1 by 2 mv square? Yes, 25 joule. So 9 into 25, yes, 9 into 25, yes, 225 joule. That is the kinetic energy when V is changeable to 3 times of velocity. Yes, I hope understanding well. Thank you. See you in the next video.